Okay, I think we have settled down for the attendees. So thank you everybody for joining us for the Scientific Assessment of Climate Change and its Effects in Maine webinar by the Scientific and Technical Subcommittee this morning. I'm joined by co-chairs Ivan Fernandez and Robert Marvini, who will be presenting an overview of the Scientific and Technical Subcommittee's final report for the Maine Climate Council. And at the end of this presentation, we'll be taking questions from members of the Maine Climate Council. For our attendees, you'll be in listen-only mode, and I will be putting a link in the chat a little later on to let you know where you can submit any questions if you have them about this report. So with that, I'm going to give you a quick Zoom overview for our Maine Climate Council members and those of our panelists listening in. Please stay on mute when you're not actively speaking. If you would like to ask a question, please go ahead and in the participants tab, raise your hand, or you can send me a message in the chat as well, and I will call on you during the Q&A session. And with that, I'm going to turn it over to Ivan to start us off.
Okay, thanks, Cassie, and thanks everyone for being here this morning. And we're here to talk about the report that was recently released. If I can get there, we go. By the Maine Climate Council Scientific and Technical Subcommittee. The report was developed by 37 co-authors, of which 28 are the appointed members of the Scientific and Technical Subcommittee, or STS. And 57 other contributors are recognized in the acknowledgements for their contributions to this work. Thus, the report is the work of well over 94 mostly Maine scientists who contributed their time and expertise, most with international reputations, as well as a history of knowledge and commitment to the state of Maine. This was not a funded assessment, and we had a short timeline to deliver critical scientific information about the effects of climate change in Maine in support of the work of the Maine Climate Council's 6 working groups and the Maine Climate Council itself, or all of you. The STS delivered what we called an initial working document at the Maine Climate Council's January 29th meeting in Augusta, specifically to provide information as soon as possible in support of the ongoing deliberations of the working groups. The STS then continued to work on further developing the document, with the goal of delivering a report to the Maine Climate Council by the meetings to be held in September, which turned out to be meetings on September 9 and 16 earlier this month. The Science and Technical Subcommittee continues to work in support of the Maine Climate Council and in developing the Maine Climate Action Plan through 2020 and beyond. The intent of the webinar this morning is not to repeat the day-long series of more detailed talks by various members of the Scientific and Technical Subcommittee that we provided in January at the beginning of this year, which feels like 10 years ago to most of us at this point. Rather, Bob and I will provide some comments on a few key highlights of the current report. A few others may chime in that discussion, and then we'll open it up for questions from council members. The report differs from the earlier working document in that some chapters are significantly more developed and new areas of focus and additional chapters have been added during the process. Some of the members of the Scientific and Technical Subcommittee are on the webinar with us this morning. We're able to be here and they'll be available during the discussion to answer questions as well. As already noted, the STS will continue to serve as a resource for the Council. And we're happy to respond as called upon and have worked with many of you in various contexts over the past 9 months. Before we begin, it's useful to revisit the legislative responsibilities of the STS that are largely embodied in this report. And I'm going to briefly paraphrase. They included, number 1, to provide the latest information on direct and indirect effects of climate change in Maine, with a particular call out for specific science-based projections of sea level rise to 2100, including map deliverables for the Maine coast. Number 2, identify options for quantifying carbon emissions and sequestration. Number 3, identify methods to build resilience. And number 4, identify critical scientific information needs in this regard. The scope of this work was not to repeat certainly the vast amount of work that was going on in the working groups during this period of time, but to be largely focused on the science assessment and the critical information needs and other information that came from that process. So before we begin, Dr. Cassandra Rose, as most of you know from GOPIF, is going to give us a couple of minutes about how the STS report will be utilized in the development of the Maine Climate Action Plan due to the governor and the legislature on December 1, as we all know. Most of you all know Cassie by now. If you don't, you've never heard of email. Bob and I and the rest of STS have been fortunate to have her as our assigned GOPIF staff member, as she's been an invaluable communicator and an accomplished scientist during the process. So thank you very much, Cassie. And with that, I'll switch slides and go. It's your turn.
Thank you, Ivan. I appreciate that. And it's been a real pleasure to work with all the members of the Scientific and Technical Subcommittee throughout this entire process. And on behalf of the entire GOPIF team, we just want to thank you very much for all of the extraordinary effort and time that was put into pulling together this remarkable report in a very accelerated timeline. So this is probably a pretty familiar process timeline to most of you so far, but the Maine Climate Council is nearing the end of a 14-month process to develop the Climate Action Plan, which, as Ivan mentioned, is going to be delivered to the legislature and the governor on December 1st. And so the Scientific and Technical Subcommittee and the working groups came up with quite a bit of information as well as recommendations for different strategies to reduce our contribution to climate change and to become more resilient to its impacts by June of this year. And over the summer and this fall, the Maine Climate Council is considering all of these recommendations as well as information from the Scientific and Technical Subcommittee and economic impact analyses of the strategies to help inform their selection of and prioritization of the strategies that will go into this first iteration of the Climate Action Plan. So this is the first in a 4-year cycle of climate action planning for the state. It is, the Maine Climate Council is a group that exists in perpetuity and will continue to meet at least quarterly moving forward after the Climate Action Plan is finalized to monitor progress on the plan. And the Scientific and Technical Subcommittee and working groups will also meet at least twice a year to monitor that progress, and will be coming out with their work plans early next year. Next slide, please. So some key deliverables from the Scientific and Technical Subcommittee in this report are a general summary of the impacts of climate change across the state, I think with a particular focus on our health, human and animal health and environments, the economy, and forest and agricultural systems. The report also includes sea level rise projections out to 2100, as mentioned before, and Bob will be going over those in a few slides. An initial estimate of the contribution of our forests to the state's annual carbon budget, which is an important first step in the compilation of a more complete carbon budget for the state. Identification of some priority information needs and data gaps about conditions in or for Maine, and then also identification of methods to build resilience to the impacts of climate change for our species. This last one in particular is something that was called out in the original legislation as a deliverable for the Scientific and Technical Subcommittee. So this final report is going to be an essential component of the State Climate Action Plan as a whole. The STS was charged with providing all of this information and deliverables to the working groups in the Maine Climate Council, and this information has helped to inform the development of the draft working group strategies and will continue to inform the Maine Climate Council deliberations in the coming months. And so the report will essentially be a chapter in the State Climate Action Plan, but it will also be woven into the different strategies of the Climate Action Plan itself. The sea level rise projections are a specific deliverable that helps the state to plan for the impacts of sea level rise both now and into the future. And these likewise will be updated every 4 years along with the State Climate Action Plan. So with that, I'm going to turn it back over to Ivan and Bob.
Okay, thanks, Cassie. So we'll launch into a series of slides here and just touch on some of the highlights of the report. Again, we're not repeating it all. Before we start that process, which is focused on the main evidence, it seemed appropriate to, both from the standpoint of scoping as well as the reality of the times we live in, to recognize that we're doing all of this in the year 2020. And as we all know, it's been a remarkable year on a lot of different levels. We've got a pandemic taking place around the planet, public outcry over racial and social injustices, and a cascade of evidence from a changing climate that ranges from dozens of wildfires in the West burning their way through 5 million acres, killing more than 30 people and forcing tens of thousands from their homes. Plumes of smoke have extended to the East Coast and across the Atlantic to Europe. And a nearly unprecedented 24 tropical storms and counting have raced across the Atlantic, 23 of which are hurricanes, and we ran out of names and we're onto the Greek alphabet. We had flooding and derecho storms that Sean Burkle can explain the process for, of how they're formed. Drought in the West and of course drought in the East. And an uninhabitable record hot temperatures in the Southwest, while another chunk of Greenland's ice cap breaks off with accelerating melting and record low Arctic sea ice. Most everyone on this call knows this and we're living it, but these are indeed remarkable times and you don't have to look far certainly to see the evidence of a changing climate. Our report did not try to capture what's going on throughout the planet, including these recent events per se. And so we recognize that the science that we're describing is specific to Maine, because that's what is often most important to drive Maine policy and decision making. And yet we're doing this in a relatively remarkable time with ample evidence all around us that we're not alone. And there's obviously a lot of evidence that oftentimes others are dealing with even worse consequences and concerns than we have. So with that kind of backdrop, I'm going to skip Cassie's slide. I'll talk a little bit about the evidence then that is in our report, sort of based around the chapters. Maine's climate is warming. The statewide mean temperatures increased by 3.2 degrees Fahrenheit since 1895. Those time series on the left are showing you the trend, lots of interannual variability, but the pattern and the trend over time is unmistakable. Minimum temperatures, overnight lows have increased more than maximum temperatures throughout the year. Coastal climate areas have warmed slightly more than the interior of the state. Everything that's cold is warming faster than everything that's warm. So minimums are warming faster. Winter has been the most warming of the 4 seasons. The 6 warmest years on record have all occurred since 1998, but we'll only be able to say that for a couple of more months. So when the records for 2020 come in, it'll probably then be from 2005 on for all of the 6 or 10 warmest years on record. So it's clearly warming, and the global warming, climate change, we all know, is far more complex, but warming remains a key driver. With more warming in our future, these are climate model projections that Sean Burkle developed based on the IPCC representative concentration pathway scenarios of 2.6, 4.5, and 8.5. And that's what you see. The squiggly line up to here is the real deal. It's what we're experiencing, and these are the projections going forward. 8.5 is lots of debate about the appropriateness of that. Nevertheless, this is close to the trajectory that we're on now. And what we're hoping to achieve is bending this curve dramatically in order to look something more like the lower curve. So Maine's annual mean temperature will likely warm 1 to 4 degrees Fahrenheit by 2050 above a 2001-2018 baseline. So that's 100 years later than some of the other baselines that we see. And up to 10 degrees Fahrenheit by 2100. The future trajectory of these warming, of course, is strongly a function of the decisions that we make now relative to greenhouse gas emissions and our use of fossil fuels and land use. Biodiversity in Maine is threatened. Our iconic species are experiencing multiple threats from climate change, having to do with shifting winter and ice cover, shorter winters with less deep snow, rapid expansion of pests, heat stress, lack of cold water refugia, among other stressors. And all species are being stressed. We hear about the sixth great extinction, declines in biodiversity occurring throughout the planet. And Maine is experiencing certainly that, which is strongly driven by these climate drivers. Maine's forests and Maine's annual carbon budget was estimated by a group at the University of Maine and with Maine Forest Service participating. This was a very preliminary estimate to try to understand what is the carbon balance for the state of Maine. And the cartoon here on the right is kind of the simplified version of major stocks. Stocks being, you know, the amount of carbon that's in forests or in farms, in forest soils, farm soils, et cetera. And the major fluxes. And so how much is being taken up by the forest, how much is being emitted by fossil fuels, et cetera. And the calculations from this estimate showed us that carbon stocks and annual growth are sequestering perhaps 60% of the greenhouse gas emissions. That doesn't mean a molecule that's emitted here is the same molecule that the tree is taking up. But on a spreadsheet basis, the mathematics work out that forests are accumulating carbon. Forests are growing faster than they're releasing carbon. But right now, it's not always that case over time. And so the uptake of carbon by these forests is, the accumulated uptake is approximately 60% of the amount of greenhouse gas CO2 equivalents that are being released in the state of Maine based on the most recent DEP reports of greenhouse gas emissions. Forest products, durable forest products, dimension lumber, mass timber, things that are around for a long period of time are another important sink for carbon, and they take up about 15% of the additional carbon. So the forestry sector is currently responsible for or credited for about 75% of an offset, if you would, or of current Maine greenhouse gas emissions, a few more percent if we count urban forests in this calculation. Maine agriculture is at risk, as well as there are some opportunities. On the left there is an image of and Glenn's on the call, but a report data from Aaron Roche and Glenn Kaler about Maine tree fruit crop insurance claims, and you see a lot of different weather-related events, and certainly drought is going to be much bigger in 2020 than we see here, which I think this was 2017. But cold, wet weather, summer hail, freeze, and frost. We have longer growing seasons with a northern shift in plant hardiness zones, early spring warm up, and increases in frost risk when these frosts occur during the early spring. More frequent and intense heat waves, more frequent and intense downpours. those 3, 4, and 5-inch rain events, particularly on fallow fields, move a lot of soil where we don't want it pretty quickly. And more frequent and longer dry spells. And since 2016, we've seen drought become part of the annual challenge, and certainly 2020 is historic. We have a statewide drought right now with a drought disaster declared by Secretary Perdue for Aroostook County. Human and animal health risks are many and varied related to climate. The sequence of plots on the left are products of work that Sean Burkle and Susan Elias had done, looking at the accumulating heat from the warming that's allowing the expansion of ticks, success of tick-laying eggs in Maine. And we all are, I think, pretty familiar with the risks of tick-borne disease, particularly Lyme disease, and as well as mosquito-borne diseases, which are expanding. Extreme heat days and heat-related illnesses are an accumulating challenge. Drought and wildfire effects on water quality and respiratory health. Wildfire, of course, is typically something we think of as not all that common in Maine in a humid, temperate climate. But with the drier weather, obviously we have increased frequency. We've got over 900 wildfires in the state of Maine this year, and we're breathing the smoke from out west. Extreme weather risks, extreme weather events are risks to humans and animals. The climate drivers increase the risk of Vibrio bacterial infections in marine waters, HABs in Maine lakes, harmful algal blooms. Pollen, the pollen season and the allergenicity of pollen is increasing. And all of this, combined with everything else we're dealing with, are accumulating stressors for mental health. And we have a chapter in the report on the economy. We have particularly two outstanding economists that led this. We did not have our report focused on the biophysical effects. It didn't include a deep dive in engineering. It did not include a deep dive in the social sciences more broadly. However, this chapter discusses economic risks and opportunities in the various sectors of the Maine economy. And the plot on the left highlights how gross domestic product, or the economic vitality in the state, is relatively uncoupled now from greenhouse gas emissions. And we see the Maine sort of leads in right now the nation in that trend. The report presents some initial findings on natural climate solutions in agriculture and forestry, which is code for different ways that we can use forests and agriculture to sequester or to take up carbon. A lot of that work led by Adam Dagenau at the University of Maine, and included in this chapter. And so with that, I'm going to turn it over to my colleague, Robert, and he'll take it from there, and I'll drive.
Okay, thank you, Ivan. So I will touch briefly on the chapters related to marine and ocean systems. Next, please. So starting with ocean temperature, it's not surprising to anybody on this call that it's been warming very strongly over the last 15 years. And you can see the graphs from Booth Bay Harbor and the Gulf of Maine, and then some instrumented buoys at several depths in the near Gulf. And there's a pretty rapid increase trend in the last 15, 20 years, as seen on this graph. And under all the scenarios, the ocean, Gulf of Maine, and the ocean in general will continue to warm through at least 2050. So next, please. And here are just some scenarios if we all took some very aggressive measures to reduce emissions we might face a stabilization around 2.7 degrees above the long-term average for the Gulf of Maine, and that's that lower blue curve there. But under a high emission scenario, we may add almost 5.5 degrees above that in ocean temperature. So it really depends on what avenue we take in terms of emission reductions. And you can see that the changes the water would feel like we were in Rhode Island and various parts of the state of Maine. So turning now to ocean acidification, it's been dropping and dropped 1/10 of a point since 1800. But by 2100, there may be additional decrease in pH. And again, it really depends on the pathway we choose in terms of global emissions. Ocean acidification is very complicated, and it involves a lot of activities from the near shore on out into the deeper ocean. So it gets complicated to predict with great detail. But it's certain that the impacts will be greatest on those organisms that use calcium carbonate to build their shells. So that's a very serious consequences for the state of Maine. Next. And the marine ecosystems, clearly warming has been a key driver of this northward shift. Just two diagrams from the suite of diagrams in the report showing the biomass shift from the southern parts of, well, south of New Jersey, really, all the way up into the Gulf of Maine. And this is going to continue with warming. And given Maine's, we have a huge dependence on the marine ecosystems for our economy, tourism, et cetera, this can have a very significant impact on the state of Maine. And it's very complicated, the interplay of the ocean warming, ocean acidification, circulation, sea level rise, and we're really not clear yet on what impact that's going to have on the marine ecosystems. Moving on, next. Sea level rise. Again, this is really a review from earlier presentations to the Maine Climate Council. But sea level rise is primarily from two causes. One is the thermal expansion of the ocean as it warms, and the second is the volume increase due to melting of ice that's on the land. So those two contribute around 90%, and all the other factors are only 10% in terms of sea level rise. Next. So coming closer in to Maine, we can look at the Portland tide gauge. First of all, we know that since we were able to trace out the curve of sea level rise since the deglaciation 15,000 and more years ago on the Gulf of Maine. And we note that over the most recent 5,000 years, the rise has been relatively slow, only 0.3 feet per century. Now here's the tide gauge from Portland showing from 1912 to 2019 that the sea level rise has been about 2 millimeters a year, or 7.4 inches per century. So already a pretty dramatic increase over the prior 5,000 years. And then if we look at the last 10 years, since the last 25 years, we see that the rate is over 3 millimeters per year, or almost over a foot per year. So we're really seeing an acceleration in sea level rise. Next. And one of the impacts is what we refer to as nuisance flooding. It It happens frequently, you know, a perfectly fair weather day and streets in Portland get flooded. So here's a diagram from the, based on the Portland tide gauge from 1912 on, showing how often this flooding occurs above the 12-foot flood stage in Portland. And the black line shows the average for the duration of measurement, which is about 3.5 events per year, 3.4 events per year. But from in the last decade, that has increased to about 12 times a year, and that's the red line. Now, if we look at the next diagram, this is what it would look like if we add 1 foot of sea level rise to the measurements taken during the last, during that period of record for the Portland tide gauge. So there would be, the gauge would exceed, the water levels would exceed flood stage 54 times a year. That's a huge jump, 15 times increase in flood frequency in the Portland area, and even an enormous number for if we looked at just the last 10 years of record. So this is a direct impact of sea level rise. We're feeling it today, and with just a modest 1 foot increase in sea level, we'll experience this many times more than we do today. Next. So we can look at various sea level rise scenarios for Portland and the coast of Maine. And the dashed lines represent the 50% probability along each of those scenarios. And they're shown there in the different colors. On the bottom, intermediate low scenario, and then in red, intermediate scenario. And these are all based on emissions scenarios. So our group, Joe Kelly, Steve Dixon, and Pete Slavinsky worked with the rest of the committee to review these scenarios and look at the probabilities for them to be exceeded given the various climate scenarios that we're working with. And so the intermediate low, that low blue line that rises 1.6 feet by 2100, that has a pretty high probability of being exceeded if we follow this RPC 4.5 or 8.5, 73 or 96%. So that's not a terribly good scenario to base long-term planning on. The intermediate one, shown in red, the middle of that range is 3.9 feet. And it still has some smaller potential to be exceeded by the various emissions scenarios. But we think this is one that it makes sense to focus on in terms of a policy recommendation. Next, please. And just to raise the awareness, we have mapped out these various scenarios for the entire coast of Maine. And you can find this on our website, the Maine Geological Survey website. And you can scan any part of the coast of Maine and pick any of the 6 scenarios and look at the impact on any particular area of interest. So, and that's based on the best available LiDAR elevation data. So it's a very good planning tool. Next, please. So this is what the Scientific and Technical Subcommittee is recommending for a policy on sea level rise. It's to commit to manage for a likely range associated with the intermediate scenario. So that would give us between 1.1 and 1.8 feet by 2050, and perhaps as much as 3 to 4.6 feet by 2100. So these are very significant sea level rise figures, and it'll mean some real, we really have to focus policy to be able to adjust how we manage in the coastal zone given this potential. We also recommend that we prepare to manage for a higher level of sea level rise associated with the high scenario. So manage for the intermediate, but get ready to manage for this higher level that may bring us to 2.5, 3 feet by 2050 and almost 8 feet to a little over 9 feet by 2100. So those are our recommendations. And I think that's probably my last slide.
Yep. Okay. All right. Thanks, Bob. So we're just going to wrap up and take a few minutes to talk about the information needs work that went on as part of the STS deliberations. In the report, there's a spreadsheet that has more detailed recommendations that, again, grew out of our discussions. And then there's a very short chapter that's in the report now that has a summary of main themes that occurred from those. And we can divide the information needs into 3 groups. And so I'll just very quickly talk about what those were. Cross-cutting priorities included sort of the really core types of research and information that's needed. Better understanding of the historical and predicted climate and for Maine and issues around extreme weather. Looking at alternative scenarios, we've seen what that looks like in these slides relative to future projections of temperature in both the atmosphere as well as ocean warming. And those are really critical for making policy decisions about what we should prepare for and the level of investment to put towards priorities. Better understanding of the vulnerability of Maine's species and the habitats that support them, particularly unique habitats like climate refugia, which are areas that can support particular species when the rest of the environment may have changed, so it is no longer supportive of essentially the survival of that species in the state. Comprehensive life cycle analyses comes up over and over again. Life cycle analysis is a field unto itself, a relatively complex analysis that tries to consider all of the implications of decisions being made. When we make decisions here in Maine, does that have an impact on what people do someplace else? And in some cases, that may negate the very purpose of the policy or the management decision. And so we want to better understand more comprehensively the implications of the decisions that we make. We need to take this initial first cut of a carbon cycle and do a lot more work to better understand carbon cycling in Maine and greenhouse gas dynamics within that in Maine across both the natural sector and the built environment. And benefit cost assessments are critical for making decisions. We've seen that already in the work of the council relative to some of the input from ERG. And that needs to be continued and expanded in order to allow us to invest resources in the highest priorities that return the biggest returns on those investments to the people of Maine. The targeted priorities were sort of specific things that arose that we wanted to call out. We have, as Bob just described, a lot of resources, work to be done, but a lot of resources on coastal flooding, and we need to strengthen those, which is the second bullet here. But the first one is riverine flood maps. And so we don't have the same kind of information, and yet we have a lot of acreage in the state of Maine along our major rivers. We're fortunate to have them, but they certainly have a consequence to the landscape that surrounds them during a flood. Research about the ecology of systems, particularly foundational species. The marine scientists can describe the importance of the copepod calanus in those kinds of systems, and those can be the Achilles heel of ecological systems in Maine as climate change progresses. Forest bioproducts, meaning what we can do with resources from our forest, particularly wood, nanocellulosics, CLT are new terms in the lexicon beyond typical dimension lumber, but really have a lot of promise both for sequestering carbon for long periods of time, offsetting or avoiding the use of fossil fuels, and building Maine's economy. Farm and food system vulnerabilities, that's really a very broad and comprehensive category. Farms are at risk on a lot of levels. We need to understand those risks and systems that can support the farm community, which is vital and vibrant here in the state. And food systems, we've already seen this year an example of how some of those vulnerabilities can be quickly exposed. That's the kind of work that needs to be done in order to reduce waste in our food systems and enhance food security, which are major concerns, both for society and our climate. And then finally, monitoring priorities. It's kind of, you can't manage what you don't measure. There's a long list of things that we are monitoring and we need to strengthen, like air quality and characteristics of snow and disease vectors. And there's some that we're not monitoring and we need to, or measuring or have a monitoring system for, and we need to establish those and improve those. There was a particular call out for the Narracus humane mooring array in the Gulf of Maine, and others on the call can tell you all about that better than I, but that has been a key resource relative to understanding or having data for the Gulf of Maine, and needs to be continued and supported. All of these data streams are critical, but if we don't use them, then there's no sense in collecting them. And we need more decision support linkages to these data streams. Decision support linkages is kind of a buzzword to say we need easy access to the data. When we pick up our cell phone and look at the weather app on our phone to see what the weather's like, that's a really user-friendly app that's accessing nationally available data. And there's a lot of data. Some of the folks on the call here are building, for example, decision support linkages with for the farm community, Sean Burkle and Glenn Kaler, that takes data for very targeted uses. And we certainly see that in marine system as well. And we need to develop and track ecological health indices. Indices are metrics that incorporate a number of different variables in order to better understand the health of ecosystems, and they're sort of an efficient way, once developed, to be able to monitor and track changes in ecosystem integrity and health over time. And so with that, that's sort of the summation of the categories that came out of the information needs work, and concludes the comments that we were making, Bob and I, on the key highlights of this report. I'm going to turn it over to Cassie now, or back to Cassie, to manage this discussion period. And so I don't see you. Oh, Bob?
First, I'm going to make one correction. I think somewhere in my presentation, I referred to sea level rise as happening at a foot per year rate, and I meant foot per century. So let's just make it clear that we're not talking about an enormously drastic sea level rise. We're talking, 50 years, 100 years, not magnitude of a foot in a year. Just wanted to make that clear.
Thanks, Bob.
Thank you. Although I do recall from that chapter that an abrupt sea level rise over the course of a year of nearly a foot has been observed in the last 10 years. And so variability within the sea level rise trend is definitely possible. So thank you both very much for that overview of this report. I'd like to open the floor to our members of the Maine Climate Council on this call to begin asking questions. And just as a friendly reminder, you can raise your hand as Representative Bloom has done using the participant tab, or if you're having a little trouble, feel free to turn on your camera and just wave and I will call on you as well. So I'm going to open the floor with Representative Bloom's question.
Thank you, Cassie, and congratulations to this group for all the hard work. It's a really great document, and I think we all appreciate it in the state of Maine, and we appreciate our scientists and all the hard work that they have done. But my question is about sea level rise, an abrupt sea level rise, as you know, what about the Antarctic ice sheets and that threat? Is that a threat, and is that a threat for abrupt sea level rise in Maine? And what have you done about that scientific research, and what do you see us needing to do in the future to monitor that?
Well, as Cassie noted, we do see a lot of variability in sea level, and so we're looking at trying to look for the long-term trends. For your specific question, I'll ask Steve or Joe to comment on that, because I know they've been looking at this most recent information on the Antarctic ice sheet. What do you guys want to respond there, Steve?
Thanks, Bob, and hello to everybody on the Climate Council, and thanks for hosting us today to GoPIF. The question about Antarctica is a very valid one, and Antarctica is changing and being studied very rapidly right now. The abruptness that we're going to experience here is probably more likely to come from meteorological and ocean circulation effects than it is from short-term ice melting in Antarctica. The real role of Antarctica is longer-term trends being jacked up to faster rates than we're seeing now. So it is a concern, but it probably is not a concern in the abrupt sea level rise arena as much so as changing in the speed of the Gulf Stream, for example. If that answers your question.
So that means that we just have to monitor it, but it's not, is it part of the calculation for the highest sea level rise scenario, for example? Or is it something that we're just going to have to keep revisiting and understanding how it affects the long-term scenarios?
Right. Yes, it is in the NOAA projections that we used, the Sweet et al. In 2017 projections. Antarctic melting is in that. Now, since that paper was produced, there are more studies coming out all the time suggesting that the amount of melting in Antarctica is even greater than what we've used in our scenarios. So if anything, that will push sea level higher in the future on those projected curves in the next assessment that the United States Climate Assessment puts out that's based on some of these curves that we've used. So there'll be a tendency for these curves to go up based on the science since the 2017 projections by NOAA.
Great, thank you.
Mm-hmm.
I'll also just note there that I was involved in the 1990 IPCC report, and our sea level projections then, you know, there was a high range, a low, an intermediate. You know, we just left things out. It was there were errors of omission, but we really followed the high trend when many of us did not expect that would be the case. There are uncertainties in areas where we, you know, really pushing ourselves now to catch up on understanding things. And Antarctica is a place where things may happen in a nonlinear way.
Thank you, Steve and Joe. Anya, I saw your hand was up before. Do you still want to ask your question?
Sure. Yeah. Thanks, Cassie. So my question, I'm just trying to understand the embodied carbon piece. And I was noticing on one slide, it was talking about how embodied carbon counted for about 15% of carbon sequestration. And I'm just trying to understand like how those calculations were made. I think when I think about like wood products, I think about that in terms of there's a life cycle where that carbon is embodied, but then once that wood product is thrown out or burned, then it goes back into the atmosphere. So I'm just trying to understand like the life cycle analysis for that and how it goes into, into that carbon accounting piece. And thanks so much to all of you today for presenting. This is so helpful and really fascinating. So thank you.
Sure, you're welcome. So I'll take a stab at that. This was not a life cycle analysis. This was a carbon cycle, spreadsheet scale type of analysis, looking at what data we had, first of all, which is a major constraint, in order to do calculations over a particular period of time. And a lot of it was based on the difference between 2 years, and the number of years in between was what you divided it by. By embodied carbon, I think I understand you mean what's in the products that we referred to, the 15%. Yeah.
Yeah.
So that's a really complex issue. That's not a lead-in to avoid answering it. But you know, there's some materials that don't last very long. Paper does not have a very long life in many cases. Dimension lumber, things we build houses and buildings with that are going to last for decades to a century. That's what would be in the sort of the durable category. So this was a relatively rough, not a granular level separation, but we didn't include firewood and paper products that would be essentially back in the atmosphere inside of a decade. And we took the available data for the other types of products. Does that get at it?
Yeah, no, that's really helpful. I think I'm just struggling with like on big time scales and carbon cycles, and maybe this is for I need to do more research on my own, but just wondering when we're looking at carbon cycles, what's worth paying attention to in terms of like making recommendations for the forest industry and things like that. But,
no, that's great questions. And so once you get out to a century, these durable products they're not going to last forever, of course. And so we're talking about these durable products. We're thinking that they're going to be around for well past 2050 out to 2100. I think of it, put it that way, in sort of that category. And materials that have a relatively fast cycle going to end up back in the atmosphere inside of 10 years. Those aren't, in my mind, those aren't really sequestered. The carbon's still in the atmosphere, and ultimately, in order to bend the curve the way we've talked about needing to do, it's what the atmosphere is that is most critical. But how to handle that over longer periods of time is a great question. It's both in building the budget, it's both what we know about right now that we can measure, and then the challenge of what we can predict relative to the various components of that carbon cycle. You can go to the website at the University of Maine, download a fact sheet that's got sort of the tables that go into this, or just email me and I'll send you the link that could give you more information.
Okay, thank you so much.
Yeah, thanks, Anya.
Thank you. Next, I'm going to call on Ben for his question.
Yes, thank you. So as the climate gets warmer, what effects will that have on the makeup of the forest species mix? And what effect will that have, if any, on the forest's ability to store carbon? And how may that affect the forest products industry's economy?
I can take a stab at that. I think that covers a lot of ground as a question. I think it will change the growth. It will, in the short term, there's reason to believe that we may grow trees faster in a warmer climate. as long as there's adequate moisture, rising CO2 acts like a fertilizer. But there's other factors that can limit that rate of growth. There'll be changes in the assemblages. So the characteristics of trees are such that they are not going to move necessarily in mass as a community, but we may have new assemblages. Trees like pine and oak are favored by the warming climate, and red spruce is not. That said, red spruce is growing right now better than it has in a long time as a result of some of the changes in the climate. So we're talking about the niche, the ecological envelope that supports these species is migrating, and how fast the trees catch up is a separate question. You know, we have major disturbances that are can be in part driven by climate. Certainly drought is one, fire is one, insects and disease, hemlock woolly adelgid as an example, are changing the composition. So we have a fair amount of knowledge to be able to model forest growth and development based on what we know from the past. And we have improving knowledge on being able to incorporate these factors into what happens in the future. Like with any other projection and modeling, we need to think about it sort of in alternative scenarios, because obviously what we do relative to greenhouse gases will drive the climate of the future, which will then reflect differently in our forests. And there's stochastic events that we can't predict. I would argue that, you know, 2020 is one with the severity of the drought that we're experiencing, and we're learning how these forests will respond to it. So that's more hand waving than a specific answer. It will change. And it will have both positive and negative impacts on that forest. And we know enough to help make decisions relative to management and silvicultural prescriptions going forward, at least in the near term.
Thank you. So back to Representative Bloom, and then I will call on Pat.
Thank you, Cassie. Ivan, you said that you had cross-cutting research issues, I believe, and monitoring priorities. This science and technical group didn't really put together recommendations per se like the other working groups did, but so did all of those monitoring priorities, cross-country research issues, did all of those get spoken about from the working groups that were affected by them? I just want to make sure that when I'm not looking at a new set of recommendations from you, I guess. I just want to be clear about how that, I mean, a lot of the stuff, I think, we did work with you in terms of the coastal marine working group. We worked on some of this monitoring stuff, but is there other stuff in here that the groups did not get to? In other words, do you have your own recommendations?
I think if we go back and look at the cross-cutting, the answer is probably no, because some of these are embodied in the recommendations of the other working groups. So these, I look at these as reinforcing. Both the scientific deliberations highlighted this as a priority, and then a working group would highlight it as a priority. You know, the climate extremes, obviously we dealt with that directly as a chapter and through all of the chapters, and so we're highlighting the need for a better understanding in that regard. I don't recall working group recommendations that called that out specifically. And Cassie, you probably have in your head all of the working group recommendations better than us. I don't know if you have a thought on that.
I think there are just a couple of areas. Yeah, I would say generally the monitoring recommendations coming from the working groups are probably fairly similar. The Scientific and Technical Subcommittee research priorities list certainly, I think, gives some detail and gives some suggestions and guidance to research in general moving forward. And I'm trying to think of I think that the flood mapping recommendations in particular, I want to say that the coastal marine monitoring recommendation may have included that. So I believe it for the Maine Climate Council members, it's certainly worth reviewing. It's not a particularly long list, and it may be helpful not only to the state, but also to research institutions around the state who are looking to fill some of these gaps in terms of providing a little bit of guidance to providing data that's useful moving forward.
Yeah, it seems to me that we really, that we have to make sure that if there are some hidden not hidden, but if there are recommendations that aren't really covered by the other strategies, strategy recommendations, that we should make sure that we've got everything in that, in our suite of strategies, I guess, that this is all included in our suite of strategies.
Yeah, and I agree. I think we need to put all of the information needs identified from the working group strategies as well as this together. We're going to see a lot of overlap among some working groups as well as these, but we also want to be sure we capture the unique ones that are a high priority. And I completely agree with what you're suggesting there.
Thank you, Representative Bloom. Next, I'm going to call on Pat Strauch.
Thank you. Great job, Ivan and Bob. You folks have been spearheading a lot of work by good people. And just a quick comment, then a question. The interesting thing about Maine's forests is there's quite a bit of variety of species. And we have a history of adapting to using different species in our manufacturing as one species may disappear. So there's a resilience built into our forest with that diversity, but changes are coming. I think the thing I was struck by is I think we've got good technical information. This is more of a process, and I think I'd lean on you guys to help us know as a council, have we got all the analytics we need to be able to see if our first cut of recommendations hits the goals? In other words, in your opinions, are we going to be able to get to a decision matrix that takes a look at all the different recommendations and evaluate if we're on the trajectory to hit our goals? It's more a process question. Am I right in thinking you guys might be the technical advice in pulling together all these different ideas, or have I assigned you more than you want?
Yeah, you had me until you said on the technical advice, I was with you, and then said pulling it together, and then that sounded like a big job. So I backed up. So my 2 cents would be, and Bob can chime in, of course, is that, from sea level rise and carbon budgets and climate warming and alternative scenarios in some of those contexts, I think we have the boundary conditions upon which the council's decisions can be made to meet the targets that we set out to do. To then now put together all of the pieces of what's recommended to see how we get there, I think the STS members are resources to be a part of that process, but we're not sitting here ready to put together as a major project. Do we hit the target of in 2045 of carbon neutrality if we take all the recommendations that are coming in all of the different scenarios? I often refer to the wedge diagram. What are the different pieces under different alternative scenarios that we're not in the process of doing? Cass?
I think I wanted to comment particularly on achieving our greenhouse gas emissions reductions goals, that Synapse Energy Economics is working with the energy working group and some of the other co-chairs right now to do an additional model run so that we can see what parts of that wedge diagram need to be adjusted to actually meet our 2050 goals, greenhouse gas reductions goals, and even beyond. So a little more information is coming on that, so that hopefully we can figure out which strategies will help us adjust those goals, or where there's still a little bit of a gap to be addressed. I would say in terms of the resilience goals, they're fairly broad. And so I think as we implement the strategies and as we see how conditions change, probably in general, the Climate Council and the STS will get a better idea moving into the future of how we're doing on those. But I think that's a really interesting question. I didn't know, Bob, if you wanted to address this as well. I saw you also unmuted.
I really just concur with your comments and Ivan's. I think we've pulled together a tremendous body of information that that bears on, you know, the impacts of climate change and likely scenarios looking forward, and those can be the basis for you know, kind of the backstop, the foundation for policies that we need in order to achieve the goals.
Does that get at your question, Pat?
Yeah, I haven't spent as much time looking at the models, but I know the wedge chart is there. But you guys will do a reality check on that too, just to make sure we're not, you know, speculating too much on modeling versus reality. So no, I appreciate the answer. I think that helps me think about how to pull it all together. The other question I'm always thinking about, I guess you call it leakage, or are we aware of our surrounding states and provinces? Are they thinking along the same lines? Are we collectively moving? I really believe it's good for us to set a standard for all others to match, but at the same time, I want to make sure we're not operating in a vacuum. And do we feel like our region is doing a similar kind of effort and can contribute to all the goals we're setting as well? Is there any thoughts on that?
I suspect others on the call and Cassie and Bob can elaborate. To some extent, certainly, there's a lot of communication within the U.S. Climate Alliance among states in the region, and then in various disciplines, including, you know, the forestry discipline. There's a lot of coordination in the region on certain initiatives. You know, the whole natural climate solution one, for example, is a lot of coordination among the states through various different organizations.
Yeah.
So I think, yes, at least a minimal level, that's critical to have, and that's a really important point. Cass?
Yeah, that's great, Ivan. I would add to that we are part of the Regional Greenhouse Gas Initiative, which sets greenhouse gas reductions goals for our region. And so I think certainly we're part of a big regional group there that has helped to contribute to reducing all of our greenhouse gas emissions. And a number of different states are working on similar or similar climate action planning processes. Massachusetts has been working along these lines for some time. Vermont just passed a bill to begin a somewhat similar process of planning for reducing greenhouse gas emissions and becoming more resilient. So there is a great deal of movement happening in different states. And as Ivan mentioned, we're part of the U.S. Climate Alliance. And so there is a lot of peer learning and discussion between different states, 25 different states around the country, a number of whom are in our own region as well.
Well, good. I think those are good answers. I'm always thankful that we're in a state with lots of trees and low population, so we can do things other states can't do. So that, good. This will be interesting. Our next, so many weeks we have to put together the plan.
If I might comment, I think we all share your concern, Pat, that we don't put in place policies that simply shift fossil fuel use to some other jurisdiction, because doing so really does not solve the problem. So, I mean, we've been thinking about that throughout our deliberations in the STS committee.
Great. Thanks.
If I could make one additional comment, I think the research, the cross-cutting priority around Maine's carbon cycle in particular is one that will really assist the Department of Environmental Protection in developing a more comprehensive carbon budget in 2 years, so that we know both what we're emitting as well as what we're sequestering. And so that research in the next 2 years is going to be really important for tracking progress along the way towards our goals. And so I think
that's on a 2-year time frame.
It is on the 2-year time frame, yes. So in 2022, the DEP is supposed to begin reporting on estimates of how much carbon we're sequestering. And I know that the University of Maine report on the initial estimates of the carbon budget talks about where they were able to make estimates and what areas still need more work. And I believe in the coastal marine environments in particular, there aren't really great data or understanding yet of the size of that sink in our carbon budget. But I know that's an active area of research, and hopefully in 2022, we'll start to get a first look at the size of that, the complete sink.
Good. Thank you.
Wonderful. Thank you for the great questions. I want to open it up again to any of our Maine Climate Council members who are still on the call with us this morning. Okay. Anybody else who's a panelist and not an attendee? Do you have any quick questions before we wrap up this morning? Okay. Oh, there's a quick comment from Steve Dixon saying that Maine's sea level rise approach is similar to that in New Hampshire, and also the way that several Maine municipalities are headed. Thank you for that, Steve. So I think with that, for all of our public attendees who weren't able to ask questions today, I put a link in the chat to the email address you can send any questions to, Maine Climate Council at maine.gov. If you have any questions about this report, I will put you in touch with the relevant authors. And if any questions come up from our Maine Climate Council members or members of the STS in the coming weeks, I will make sure to connect you as well. Thank you all for joining us this morning. Ivan or Bob, do you want to make any final remarks?
No, thanks everyone for being here, and thank our fellow STS members who could make it this morning for being on the line. Thank you, Cassie.
Yeah, and thanks to all the contributors to our report. It really was a huge effort, and everybody put their shoulder to the wheel and got it done. Thanks a lot.
Absolutely.
Thank you. We appreciate your attention this morning.
I have a quick question.
Yes.
Is the report is that report a standout among other states in terms of its depth and breadth? It seems to me it should be, or it might be. I'm just curious how we compare to other states with that report.
Yeah, I don't know. We haven't done an inventory of all the climate reports, and it depends on when they were actually done, you know, sort of how to stack up. It's a very substantial report that it does a deep dive. Many other states, frankly, have, you know, big grants to do it, and they take a longer time to do it. So the reports might look a little bit different in character because of it. However, I feel good about what we've provided now for our understanding here in Maine. It's very comprehensive. Obviously it's a work in progress to understand the impacts that climate is having. So I can't give you a rating, but I think we should feel pretty good about it.
Great, thank you.
Thank you all. We'll be recording this session as well and providing it on our YouTube channel by early next week. Thank you everybody for joining us this morning. Again, feel free to send any questions by email and hope to see you at our next webinar on the equity assessment next Tuesday.